Hi everyone! In this video, we'll be taking a look at some of the various monitor controller technologies and their respective pros and cons. The first kind of volume control we'll look at is just using potentiometer. Many inexpensive interfaces and monitor controllers use this. While most approaches to volume control have their pros and cons, a potentiometer essentially should be avoided. They can cause pretty bad degradation to the sound quality, they can have impedance issues, and can just be noisy in general. The next approach is to use something like a rotary switch with resistors. This is a completely passive approach that puts very little in the signal path. A rotary switch may seem like a potentiometer, but it has discrete steps and essentially just switches between each position. Each position then has some resistors on it, which attenuate the level. A variation of this, used in some high-end monitor controllers, is to use relays to control the step levels. The knob that you control essentially just switches between different relays and determines which resistors the audio signal goes through. These passive approaches can be very clean, but can still have noise issues. While it may seem like you're essentially just scaling down the entire audio signal and noise floor, you're really just pushing into a noise floor, so there will be some reduction in dynamic range. It's also important to note that a purely passive system can have problems with impedance, just like using a potentiometer. Essentially, every different volume position will load the system in a slightly different way. This is where an active system can be beneficial. By adding buffer stages, you can essentially solve those impedance problems inside the monitor controller itself. The downside is that there's now more added circuitry in the signal path. This can affect different factors like noise, coloration, and distortion. Again, changing the level on the monitor controller will have some effect on the dynamic range of the system. In any system, the gain staging should be carefully considered so that the monitor controller doesn't have to provide too much attenuation. A variation of this design, which isn't very popular, involves adjusting the gain of the gain stage itself. An example of this is found in some of the PS Audio products, and they call this feature the gain cell. By varying the gain, the noise floor can also be attenuated. The proposed benefit of this is that the noise floor lowers with the signal, instead of being at a fixed point. I'm not sure if any pro audio manufacturers are using this system, as it is a lot more complex to engineer. As far as active systems go, there are also certain attenuator ICs which can be found in products such as the Cranesong DACs. These can also potentially have benefits over a resistor-based attenuator. The other kind of volume control which contrasts these mentioned so far is DSP-based. DSP-based systems simply scale the digital audio signal. When attenuating, some dynamic range will always be lost. However, with proper dithering, some of that detail can be maintained below the noise floor. This can rival some of the passive and active solutions, which also lose detail below their respective noise floors. The important thing with DSP-based systems is to properly gain stage the system so that it's not being used at something like minus 40 dB of attenuation. A properly implemented system can easily handle 12 dB of attenuation without any noticeable degradation. An advantage of DSP-based systems is that there's no added circuitry in the signal path, whether it be active or passive. Certain products, like the RME80i2, will use a combination of DSP and active-based attenuation. The unit has several large steps that can jump through with the active circuitry, and then the finer details between those steps is controlled by DSP. I hope this video helps you understand the technologies used by different monitor controllers and some of their pros and cons. Feel free to send any questions.